Okay, now let's move to the third and the last part of the presentation, where we'll be showing how to do a presentation using Matplotlib and Seaborn graphs. So here we see one particular representation of your data using box plot. So here we are showing box plot for the column price, but let's come back to this example a little later, but try to find an example where the graph looks much more clearer. Let's take this as an example. So here we are showing the box plot for the column values mile per gallon within the city. And you see a box at the left side of the graph, and there is a vertical bar again, and there is a horizontal bar, and there are like few points that represent where your data points look like. So the way we'll read the box plot is there is a vertical bar within the box, blue box, and that actually creates two separate boxes. One is at the left side and at the on is the right side. So the vertical bar actually represents where the mode of your data is. So here we are saying that okay, the mode of the mile per gallon values is something around 18, and the left box actually represent your 25th percentile of your data, and then the right represent your 75th percentile of the data. And the right side are those values that are exceeding the 75th. These two vertical bars represent the minimum and the maximum value expected by the static that we use to create this box. So these are estimated values. We see like some data points that are exceeding the right bar, so it's beyond the maximum of your estimate. So these we call as outliers based on the distribution here. We can say that there are some outliers on the far right end of this graph that are telling some of the vehicles are running over 120 miles per gallon. Now we move to the other example. So here we are looking at the price, and you can see that here are few thousand, and here it's around 500,000. So the box is around here. The idea is same. So you have a minimum value and the left representing the left bar, and the maximum value representing the right bar, and your 25th to 75 percentile remains within this box. And these are outliers based on the distribution here. And we can see that we see some vehicles with 2 million values. We might have some data points like that, but these are actually far away from the distribution here. So this is all about the box plot. Another plot that you will be using a lot is the scatter plot. So here we are looking at the frequency distribution as bar charts. So you can see that in our data, Chevrolet has the highest number of vehicle, followed by Ford and Volkswagen, and only the Chevrolet has more than 1,000 vehicle recorded in the data frame, and those are the remaining are in the scale of few hundreds. Another quite usual visualization that we'll be doing frequently is what we call heat map. And one particular example of data that will be working quite frequently is the correlation matrix or correlation graph. You can use the correlation function of pandas, and that will give you the correlation of all the numeric values. So if you recall, we have horsepower, cylinders, mile per gallon on the highway, per gallon on the city, and the price. These are the numeric values. So if I just run this, I will have a graph here what we call the correlation heat map graph, and see that the diagonal elements are 1 because you are comparing against yourself, and the values are within the range of -1 to +1. So -1 meaning that you have a correlation, but it's a negative correlation, and +1 means you have a positive correlation. So you can see that if you compare year against year, or maybe like horsepower against horsepower, then you will have complete correlation, +1, and you see there are like some negative values. So this is still correlated, but it's negatively correlated, and when the values are close to 0, then means that the variables do not have any correlation, those are random. So let's look at some of the correlated values other than itself. So if you see that the mile per gallon on the highway and city, because here we are talking about how many miles you can drive on the highway, and on the city these are actually same or similar values, so we should see a positive correlation. Let's find another one that has a negative correlation. So here if values are more than 0.5 negative, so we are saying that if you have a number of cylinders vehicle that cost more fuel, so you will have a less mile per gallon, so you will need more fuel to drive those vehicles. Let's look at a positive correlation and horsepower and cylinders. So we are saying that to have a higher horsepower, you will require more cylinders. Finally, we want to see the scatter plot. So scatter plot meaning we are putting dots on our figure. So here, let's run this. So if we run, we will see a scatter plot. So here on the x-axis, we are plotting the horsepower, and then the y-axis is price. So you can see that the values are actually quite close to x-axis for most of the values, but you have certain values that are showing a linear increase. When the horsepower increases, then your price actually increases. So again, the scatter plot plots your data points as dots or circles within a graph. Okay, so this is all about. I'll post this notebook on my GitHub and share on the Blackboard, so you can run and experience by yourself. But if you feel certain things are unclear, feel free to reach out to me. Thank you.